In this lecture, we're going to learn about Lvalues and Rvalues. Lvalues are things you can store in memory on a long-term basis, and you can grab their addresses and use them. I know this may be confusing to some of you, but bear with me. I am going to try and make this super clear by the end of the lecture with the help of a few examples. Now, besides Lvalues, we also have Rvalues in C++. And Rvalues are temporary in nature in that they only exist for a short time, and as long as they are no longer needed, the compiler is just going to destroy them. So keep this in mind. Lvalues live for a long time throughout your program as long as they are in scope, and Rvalues are only meant to live for a short time. So let's look at a few examples. We are going to start with Lvalues because this is what we've been basically doing for a long time so far. We have a few variables here, x, y, and z, and we have a few values n. And these variables are Lvalues because we can grab their addresses and use them in our program. So for example, we can grab the address of x and store it in a pointer, and this is going to work. This is why they are Lvalues and they are not Rvalues. Now, what about Rvalues? Let's try and see an example here. We can use our example with x, y, and z and set up a z variable. And in z, we are going to store in the result of x plus y. Now, if we do x plus y like we do here, the compiler is going to add up x and y and store the result in a temporary location in your computer's memory. So for example, the result of this is going to be stored here, and that's going to be 15 that we have in this location. And a copy of this is going to be pasted into the z variable. Hopefully you can see that your computer is going to set up a temporary value, store it somewhere in memory, and then copy the value from that into our z variable here. That's why we say that the result of x plus y is a temporary value, which is going to be living in a temporary memory location. So as soon as the value is copied into z, the computer is going to destroy this memory location because it's no longer useful. That's why we say that x plus y is an R value. The result of this is going to be stored temporarily in memory, and it is going to be destroyed as long as it's no longer needed. This is what we mean here. So if we try to print the value of z, we will get a 15 here, but it is a copy. The actual memory location where the temporary was stored has been destroyed as long as this line executes. So this is the main difference between Rvalues and Lvalues. Again, it is possible to grab the address of an L value and store that in a pointer, for example. But if you try to do that for an R value, you're going to get a compiler error. So for example, if we try and grab the address of x plus y like we do here, this is going to give us a compiler error. If we try to store this in a pointer, that's not going to work. That's what I mean here. Let's look at another example for Rvalues. For example, if we have an add function which returns a copy. So if we add up 10 and 20 here, we're going to get a value. That value is going to be stored in a temporary location. So we're going to get 30.3, I guess. That's what we're going to get from this addition here. This is going to be stored temporarily in this location. And we are going to copy the value in here and store that in our result variable. And that's what we're going to see if we print this little guy here. But if we try and grab the address of this expression here, this is going to give us a compiler error because we can't grab an address of a temporary, which is really meant to be used for a short time and be destroyed by the compiler or the computer afterwards. Okay, here is a simple example that shows a bunch of compiler errors we can get if we try and grab addresses for temporaries. If we grab the address of x plus y and store that in a pointer, this is going to give us a compiler error because we have no business grabbing the address of a temporary value. If we do the same for our add function, we're going to get a compiler error. If we grab the address of a literal, this is also going to give us a compiler error because a literal is really a temporary value that is meant to be used to initialize your things, for example. So a literal is basically an R value, and you have no business grabbing an address of it and trying to store that in a pointer. If you try to do that, you will get a compiler error. But if we grab the address of an L value, for example, X here, and try to store this in a pointer, this is going to work because an L value is meant to be living for a long time in your C++ program. Now that you know this, we're going to head over to Visual Studio Code and play with these things a little more. Here we are in our working folder. The current project is Lvalues and Rvalues. We are going to grab our template files and put them in place. Let's do this. And we will open this little bad boy in Visual Studio Code by dragging and dropping here. This is going to give us our main CPP file that we can start playing with. And the first thing I am going to do is put in the code for us to play with. We will put in our X, Y, and Z variables, and hopefully you can see that these are L values because they have a permanent memory address as long as they are used in this program here, in the scope where they live. So if you want, for example, you can grab the address of X, we can do that and store that in a pointer address, for example, let's say PTR. And we're going to grab the address of X. This is going to work. This is going to work just fine because X is an L value. But the one thing I want you to see is that if, for example, we do Z equals X plus Y, let's try and do something like this. And print out the result of Z. We can see the value in Z and print this out. And build and run our program. We can pass this through our favorite compiler. We're going to be using GCC. Because that's our favorite. The build is good, so we can bring up a terminal window and try to run Rooster. We are going to see that we will see our value in Z printed out. But again, what is happening here? The addition here is being carried out and the result is stored somewhere in your computer's memory. For example, we're going to take this 5 and this 10 and add them up and get a 15. This 15 is going to live in some memory location on your computer, and that location is not going to be Z by default. What is going to happen is that the compiler is going to store this result in this location, and the computer is going to copy this value and store this in Z. And hopefully this can tell you that the result of X plus Y is a temporary value because it lives in a temporary memory location which is meant to be wiped out as soon as we have the value copied where it is meant to live. So the result is meant to be living in Z. So we're going to copy the value from our temporary, store that in Z, and then destroy this memory location because this is a temporary. Now, what happens if we try and grab the address of this temporary here? Let's try and see this. We can go down here and try and say stdc out and try to print the address of X plus Y. We can do that. And I can assure you that this is not going to work because we have no business grabbing addresses of temporary values because they are meant to be living for a short time in your program. And the chances are by the time you try to grab this address here, the expression here will have already executed and the temporary location you want to grab the address of may have already been wiped out. That's why the compiler doesn't allow us to do something like this. We can't really grab addresses for R values because they are meant to live for a really short time. They are transient values or temporary values. That's what we mean here. So line 13 here is not going to compile. If we try to compile it, we will see a compiler error. Let's pass this through GCC, our compiler, and we're going to get a somewhat meaningful compiler error. And we're going to see that L value required as unary with this address of operator. What we mean here, what the compiler means is that you can't really grab the address for an R value. The only thing you can grab an address for is an L value. And the result of X plus Y is not an L value, it is an R value or a temporary value. I really hope this makes sense. Just to show you another example, we can comment this out. We're going to go on top and set up a function to add stuff up. It is going to return double. The function is going to be called add, and we will be adding up A and B. The types are going to be of double, and we will just return the sum of A and B. This is going to be returning by value. And if we go down and set up a separator, we're going to say stdc out and put in a bunch of hyphens. This is going to do. and set up the code that we want to play with. Let's close our terminal window here. I don't think we need it. So we're going to comment out this line that says we want to grab the address of XY. Do we have a compiler error here? What is happening? Why can't we grab the address of X? Let's try and compile and see if the compiler error goes away, because I don't really like this. It is Visual Studio Code which was confused. So we can focus on this little thing here. We're going to add up 10 and 20 as we do in here, and we will do that using our add function. The function is going to be returning by value, so it is really going to return a copy. But what is going to happen here is that the return value of this function is also going to be stored in a temporary memory location. So the memory location may be something like this, living in some memory address. You can put any address here. And the result of this addition is going to be living in this temporary memory location. The result is going to be 30.3, I guess, as we saw in the slides. So we may have a situation like this. And after we have this stored in this temporary memory location, the value from here is going to be copied and pasted in this result variable. And as soon as we have the value in result, the temporary memory location is going to be destroyed and its job will be already done. So the result of adding up these numbers using this function is also an R value, because we can't grab an address of this. This is a temporary memory location which is going to be destroyed as soon as it is not needed in your C++ program. So again, if we try and grab the address of this, we will get a compiler error. That's what we see here. We will see that we get a squiggly line, and if we try and compile this program, we will get the same compiler error. So an L value is required for this operator here, and we have no business grabbing the address of an R value or a temporary. So if we comment this out and try to print the result, we will see that this is going to work, because now the result variable is storing a copy of what we had in the temporary memory location, which has been destroyed as soon as we have our copy stored in this result variable here. Now, if we try to build, we will see that this is going to work just fine. The build is going to be good, and if we run Rooster, we will see our data printed out. We should see a 30.3, and this is what we have right here. Another thing I want you to see as a simple example is what happens if you try to grab the addresses of these temporary values. So let's put in a bunch of hyphens to separate things. And we're going to put in code we want to play with. The first thing we will try to do is grab the address of x plus y. You already know the result of this. We have no business doing this. This is going to give us a compiler error. You see that we have a squiggly line. We can't grab the address of an R value. We are going to get the same thing if we try to grab the address of add here. This is going to give us a compiler error. And we will get the same thing. I think this is new now. We had seen all these, but you are also going to get a compiler error if you grab the address of a literal value and try to store the address of that in some pointer, because a literal is also a temporary which is meant to be living for a short time. So the moment you set up a literal like this, the compiler is going to set up a memory location somewhere which is going to store this literal. So it is going to be, for example, a 45 living somewhere in the memory of your computer. And what we are trying to do here is grab the address of this temporary memory location and use a pointer to manage that memory location. This is not going to work because this little guy is meant to live for a really short time. So grabbing its address is only going to be a recipe for disaster, because it is highly likely that by the moment you try to use that pointer, this memory location is already wiped out. So you have a pointer really pointing nowhere, and trying to use that is going to give you a bunch of crashes. You don't really want to do that, and the compiler is stopping us from doing something like this. That's why we get these compiler errors. So if we try and compile our program, we're going to get a bunch of compiler errors on these different lines. You see we have one at line 37, we have one at line 34, and we have one at line 35. And they are the same things. We have no business grabbing the address of R values, and x plus y, the expression here, evaluates to an R value because the result of this is going to be living in the temporary memory location. The result of this expression here is going to be an R value, and it is going to be living in a temporary memory location. We have no business grabbing its address. And the literal values are R values as well. And you can't grab their addresses like we do here. If we do that, we are going to get a bunch of compiler errors. I really want you to see this. I realize that by now, R values and L values are just really boring concepts, but they will become extremely important in a few lectures ahead when we start passing parameters to functions, and we have temporaries that we are passing around, and we don't really want to be copying data that we could avoid copying and improve on the performance of our application. Bear with me, we are going to see this in a few lectures, but we need to get to the basics first, and that's what we are doing here. And I hope by now you know the difference between an L value and an R value. We are going to stop here in this lecture, and I hope you found it interesting. In the next one, we will learn about R value references. Go ahead and finish up here and meet me there.